Hello. So we continue with the ETL subsystems, and in the first lecture of subsystems, I talked about the extracting process related subsystems and the cleaning and conforming data related subsystems. So basically, we have covered subsystems from 1 to 8 already. Now we are going to talk about the remaining subsystems, and let me tell you that we are mainly going to focus on the prepare and presentation related subsystems from number 9 to 21. And I feel that managing the ETL environment subsystems starting from 22 to 34 are not suitable to cover in a first course on data warehousing, but as we move forward in the course, if there is a need, I'll take them up. I have enumerated them towards the end of the slides, in the concluding slides. So just for the sake of completeness, I've put them there. So let me begin with the prepare and presentation related subsystems. So preparing data for presentation is the primary mission of the ETL system, and delivery subsystems are most critical subsystems in the ETL architecture. And despite like we have been talking about heterogeneity in various forms in the source systems right from the beginning, so despite these variations in source data structures and cleaning and conforming logic that we saw in the previous lecture, the delivery processing techniques are quite well defined and disciplined. And many subsystems focus on dimensional table processing, and because this is mainly because dimension tables are at the core of any data warehouse. Like when I started talking about designing a data warehouse, I mentioned that your data warehouse is only as good as its dimension tables, because the kind of analysis you can perform on a data warehouse is governed by the attributes that are there in the dimension tables, and these dimension table attributes provide context for fact tables. It is not that fact tables are not important. Fact tables are very, very important because they contain the critical measurements of business. But the context comes from the dimension tables. So as we have discussed, that the queries that are executed on data warehouse are typically outside in queries. Outside in queries means the queries first enter the data warehouse through dimension tables, and then they reach through the dimension tables, they reach the fact tables. So a lot of you'll see that a lot of focus will be on dimension table processing. And as I said, fact tables are important, and most of the data lies in the fact table, but preparing them for presentation is straightforward, provided we have handled the dimension tables nicely. So the first system that first subsystem is called as the slowly changing dimension manager. So, and it implements the slowly changing dimension logic, and basically handles the updates of a dimension attribute value. So suppose there is a dimension table, and it will have several attributes. So suppose one attribute of a dimension table or of a dimension record changes. So how do you incorporate this change in the data warehouse? So it basically talks about this. So this particular subsystem talks about this, and there are many different ways of handling these changes. So let me give you an overview. Open document here. So let me see. Yeah. So let me try to about these changing dimensions. So suppose there's this fact table, and these are the associated dimension tables. Okay, and now suppose there is a dimension table here, say product. Okay, so now there's a product, so there is a particular product, say P1, whose category is say is C1, but at a later point of time I decide that this P1 product should be in category C2, not in category C1. So what I'll do is, in the operational system, I'll make this change and strike off C1 and replace it with C2. But in a data warehousing environment, right, we do not strike off the values. So what we do is, how we handle this change. So this change now needs, it has been done in the operational system, so now it has to be brought into the data warehouse. So when the next ETL, after this change has been made, the next ETL, right, so whenever the next ETL is scheduled, at that time every record of each dimension table is checked against the incoming records, and if any of the attributes of a record is found to have changed, we try to incorporate that change in the data warehouse. So there are three ways of doing it. So first is type 1. So in type 1 we implement this overwrite kind of a we simply overwrite the value, which is not recommended in a data warehousing environment. So what we do is, we basically implement a type 2 change, where what we do is, we first check that which attribute has changed, and then we generate a new record. So this was my old P1 record, so it will now be a P1 dash record, which is a new record which will be generated, and it will have the latest value for the category. So there will be two records for the product P1, one with the old value of category, old category, and the another one would have the new category of records. So this is what is type 2. Although there are a lot of other things associated with this, but this is what I just wanted to share with you. And then type 3 is that whenever any attribute changes, I introduce a new attribute saying that from which date this value is effective. So I do that. So these changes, all these things will be taken up in the advanced dimensional modeling module, which is module number 5. Immediately after I finish ETL, I'll be talking about that. So you'll find more details there about all the kinds of changes that can happen to a dimension table and how they are handled in a data warehousing environment. And similarly, like so type 1, type 2, type 3 responses to updates, and recently these type 4, type 5, type 6 and type 7 have been introduced. Although the names have been introduced now, the concepts of a mini dimension or that of a, so you can see that here, let me use a different color, right. So these concepts of mini dimensions and outriggers, they are already there in the literature, but now recently in the second and third editions, mainly in the third edition of the Data Warehouse Toolkit book, so these new types have been introduced. Earlier they were not given any names, so now these names have been given, and I'll be able to discuss these changes only when I have covered module 5. So to be covered, so all these red ink types will be discussed, right, when we talk about module 5. In fact, type 1, type 2, type 3 will also be discussed, but I just gave you some idea. But to be able to tell you about type 4, type 5, type 6 and type 7, I would need to cover module 5 first. So there is a kind of a dependency of this on module 5. So anyway, I mean, you will see that a lot of things in prepare and presentation subsystems would depend on topics that are slated later, but that is how it is there. So but we'll come back to these modules, these subsystems, once we have covered these topics. Then the next is the surrogate key generator. So I have already given you some idea about what surrogate keys are, right? So they are basically like in all the dimension tables, the surrogate keys act as the primary key for dimension tables, and they are not the production keys or the natural keys that are used in the operational systems. So these are new keys that are generated, and they are typically 4-byte integer keys, right? And using 4 bytes, if I'm using an integer and I'm using 4 bytes, so I can generate close to 4 billion distinct values, so which is sufficient for most applications that we talk about. Okay, and so this particular submodule is subsystem is responsible for generating the surrogate keys for dimension tables. So what happens is that when the ETL, when say I'm looking at a product master, so I'm trying to bring in the product master into my dimension table. So when I do that, so when I encounter the first record of the product master, so there will be a key already present in that. So what I do is for each value of the key, I keep generating a number starting from 1, 2, 3 and so on as I keep on reading the records, and these numbers then become the primary key of the dimension table. So if you look at a dimension table, so there will be basically two. So one would be the surrogate key, which will be an integer, and the other would be the natural key, which is also kept in the dimension tables. Okay, so both these keys coexist in the dimension tables. But when we talk about fact tables, so the primary key is this, the surrogate key. So all fact tables will have a foreign key to the surrogate key and not to the natural key. And when we talk about these slowly changing dimensions, you will understand that what is the role of natural keys and why we do not have foreign keys to the natural keys. And also we will see that why we need both surrogate keys and natural keys in a dimension table. So all these answers will come once we have covered module 5. So surrogate keys are used extensively in data warehousing, in the dimensional model, right? And all the dimension tables have surrogate key as the primary key, and fact tables also have the surrogate keys. They do not have the natural keys. Okay, and there is a foreign key from the fact table to the dimension tables, and they connect through the surrogate keys. So surrogate keys play a very, very important role in data warehousing, and we'll be discussing that right at the beginning of module 5. Okay, so so that's this module is responsible for surrogate key generator. Then there is a hierarchy manager. So dimension tables also contain information about hierarchies. Say for example, so if you have a product dimension, so I keep referring to the product dimension because this is one that we understand very, very easily, product dimension. So it will have a hierarchy. So it will have the product at the lowest level, then it would have a subcategory, then it would have a category, and then there will be multiple categories in a particular department of the store. So this hierarchy would be present in almost all the dimensions that we talk about, and in some cases there can be multiple hierarchies that are present. Say for example, if I look at the time dimension, so suppose the granularity is day, so day can roll up to months, months can roll up to quarters, quarters can roll up to years, right? And similarly, I can also have days rolling up to weeks and weeks rolling up to year. So these are multiple hierarchies that might be present in a particular dimension table. So hierarchical information is embedded in dimension tables, and these hierarchies can be fixed or ragged hierarchies. That is, ragged means we call them in data warehousing literature, we call them variable depth hierarchies. So slightly ragged hierarchies like postal address, where say when I say slightly ragged, that means that if for me the address is coming in 4 lines, for you it may come in 3 lines, right? And for some maybe it comes in just 2 lines, right? Depending upon how you have organized the address fields, right? So address field is typically implemented or modeled as a fixed hierarchy. So whenever you talk about address, so you know like house number, street name, locality, pin code, city, address, and state. So these are the fixed attributes that are there that comprise the address field. So it is modeled as a fixed hierarchy, right? And profound ragged hierarchies, one found in organization, something similar to one found in organization structure. So organization structure can be very ragged. Some departments may have too much hierarchy, and some departments may not have too much hierarchy. And these are modeled using a concept called as bridge tables. So again, these would come in the advanced dimensional modeling module. And also we talk about snowflakes or normalized structures used by ETL for populating and maintaining hierarchical attributes. So what is done is that like if there is a hierarchy from city to state, so it is basically it introduces some kind of redundancy. So if city and state are in the same table, so what happens is that we try to normalize or snowflake the tables so that redundancy is removed. So these structures are also used by hierarchy managers. And then there is a special dimensions manager. So here we talk about dimensions that are slightly different from the ones that we know. So I can just tell you at this point of time, I can just tell you about the date and time dimension. So what is special about this dimension is that there is no source for this dimension. Like there is source for customer dimension, so there is a customer master, there is a product, so there is a product master. Like this, there is no date master or time master, right? So this particular dimension needs to be built by the user or by the designer, right? And this is typically built using a spreadsheet like Excel, okay? And so this dimension is slightly different from the other dimensions. And then there are junk dimensions and mini dimensions. The concept of mini dimensions already came up in the previous slide when we talked about type 4 change, right? So these topics again, which are marked in red, would be covered in module 5, and then you can go back and again discuss these points. Then the next subsystem is about fact table builders. So there are 3 types of fact tables. So one is so I'll clear the annotations. So fact table builders. So there are 3 types of fact tables that are present in any data warehouse, or not all of them need to be present in a single data warehouse, but generally these are classified into 3 types: transaction, periodic, and accumulating snapshot. So transaction, basically like if you go to a store and you purchase items, so each line in your bill or in your receipt is recorded in the fact table, right? So that is a transaction database. Like in a bank, you carry out a transaction, so that is recorded. If you go to a online booking site and book tickets for rail or air, right, air travel, so there also every booking has a line record. So every booking is recorded in the fact table. So that is one. Periodic fact tables, periodic snapshot fact tables. So they are basically where the each transaction is not of importance, each individual transaction, but say for example banks, so they are interested in monthly snapshots of the data, like at the end of the month how much is the balance in each and every account that we have, right? So that is a periodic snapshot. And then we have what is called as accumulating snapshot. Accumulating snapshots is about those events which have a start date and an which have a well defined start and end, like for example order processing. So order is placed, it is shipped, packaged, shipped, and payment is received, right? So this has a beginning, well defined beginning, and an end. So such processes or such events are captured in an accumulating snapshot fact table. And also we need to maintain referential integrity with associated dimension tables. I already mentioned to you that the fact tables are linked to the dimension tables through foreign keys, and these foreign keys are surrogate keys, right? So surrogate key pipeline subsystem is designed to support this particular need of referential integrity with associated dimension tables. Now the next subsystem is on surrogate key pipeline. And surrogate key pipeline is basically how the surrogate keys are generated and how they are maintained. So let me give you some background about this. So surrogate keys, as I told you, are generated for each dimension record that comes in, and each dimension table is also associated with what are called as lookup tables, where there is a mapping between the natural key and the surrogate key is recorded. So this lookup table helps in implementing the surrogate key pipelines effectively. So this again would be covered in module number 5. Then we have a multi-valued dimension bridge table builder. So most of the dimension tables have have a characteristic or have a relationship with the fact table, which is a one-to-many fact table, one-to-many relationship with the fact table. So there is a product P1. So in the fact table, you will see that there will be many records in this fact table, sales fact table, in which this particular product is sold. So there is a one-to-many relationship between the dimension table and the fact table. Sometimes what happens is a fact table must support a dimension that takes on multiple values at the lowest granularity of the fact table. Say for example, multiple diagnosis of a patient, right? So at the lowest granularity, that is a patient, so I have just one attribute for the diagnosis, right? So how do I model multiple diagnosis? So these come under the category of multi-valued dimensions. And similarly, multiple salespersons for daily sales fact table. So I have a daily sales fact table, and I have a total of I record the total units sold for a product on a single day. But now suppose I want to associate the salesperson who carried out that particular transaction. So I'll not be able to do that, because during the day there will be multiple salespersons who would be at the sales counter. So I cannot associate that. So how do we model this kind of situation? So this is actually used, modeled using what are called as bridge tables, right? And again, this bridge table concept will again come in the advanced dimensional modeling module. So the next subsystem is on late arriving data. So this talks about late arriving facts and late arriving dimensions, because you as an ETL manager, or as a person who is responsible for the ETL, you do not have much control over the source system. So sometimes due to some problems, due to some network issues, right, or any other kind of problem, data may arrive late. So how do you handle late arriving data? So this particular subsystem of ETL talks about this, right? So right now, like as I am discussing these subsystems, I am not trying to tell you about the solutions, like how these things are handled, right? but right now we are just trying to figure out which subsystem is responsible for what, and all these how part will come during the course of the in due course it will come. Okay, so we are not here discussing everything because we do not have the right background at this point of time, but at the same time we could not have delayed ETL any further. So it's a dicey situation, but we'll be able to manage it well once we have covered. I think most of the things will be covered in the next module that we are going to discuss, that is on advanced dimension modeling. So next system is dimension manager system. So it is this subsystem is the central authority who prepares and publishes conformed dimensions. Okay, so conformed dimensions means, as I told you in the previous lecture also, that they basically they basically are dimensions which can be associated with multiple facts. And instead of maintaining multiple copies, so we have this concept of what is called as conformed dimension. So this concept of conformed dimension is supported in databases. So easier to manage conformed dimensions in a single table space DBMS on a single machine, as there is only one copy of the dimension table that is kept. And it is slightly more involved when we talk about multiple table space DBMS, or DBMS is distributed over a set of machines. So then it becomes slightly more complicated, but a single table space DBMS on a single machine, so this is the most easy way to implement conformed dimensions. Then there is a fact provider system. So it is responsible for creation, maintenance and use of fact tables. And I think in the last class I also mentioned about drill across when I talked about conformed dimensions and facts. So if fact tables are used in any drill across applications, any drill across applications, then by definition the fact provider must be using conformed dimensions provided by the dimension manager, which we just discussed. So these are subsystems which mainly talk about dimensions and facts. And then we have what is called as an aggregate builder, and aggregation is a topic that will come up in module number 7 on query performance enhancing techniques. So aggregates are something like pre-computed things, like when you go to a restaurant, right, and when you order something, so if the chef or if the chef in that restaurant starts to prepare everything after your order has been received, then it will take a long time for the chef to prepare your meal. Compare the situation when based on expected order, right, not for individual customer, but I know that I get say around 50 customers in an evening, right, on a particular day, right, and 12 of them or 10 of them would order this particular dish. So what I'll do is I'll do some prior preparation, right, and keep things ready, and as and when I receive the order, I'm able to quickly make that particular dish or meal, right. So so it helps. So similarly in data warehousing, or in particular in relational systems, there are concepts like metallized views and aggregates which help you pre-compute something which is likely to be required by queries. So we do that quite often, and aggregates are the most single most I think I missed out on something, most dramatic way to improve the performance in a large data warehouse. So I think I missed out on dramatic way to improve the performance in a large data warehouse, and they work as indexes, and these aggregates are pre-computed, and aggregate builder is responsible for populating, building and maintaining these aggregates. And aggregates should ideally be maintained in an incremental way, but that may or may not be possible all the time. So we also sometimes drop the aggregate and rebuild them again. And then we have the OLAP cube builder. So OLAP cubes present dimensional data in an intuitive way, enabling analytical users to slice and dice the data. So basically what it does is, so it presents the data in the form of a cube, right? So if I look at the sales fact table, right, so there are 3 dimensions: product, location, and time. So if I do this, right, so then these are like these are different time values, these are different product values, and these are different. So any intersection of these dimensions will give me a value for the fact. So this OLAP cube builder is responsible for building cubes, which is an intuitive way to see the data and do some analysis on top of that. So what we generally do is that we allow the access to the data, to the dimensional data that we have in the form of star schemas through a OLAP OLAP cube, right? So OLAP basically stands for Online Analytical Processing, and it's a tool that works that works on top of a data warehouse. So there is a separate module on OLAP and multidimensional databases. And since most of the implementations of a data warehouse are on top of relational systems, so relational dimensional schema is a foundation. It acts as a foundation for OLAP cubes. So it's a very interesting concept and topic, and I'll be spending a lot of time on this particular module. And then the last subsystem for the day is Data Propagation Manager. So responsible for the ETL processes required to transform conformed, integrated enterprise data from the data warehouse presentation server to other environments for special purposes like data mining. Say somebody wants to mine the data that is there in the warehouse. So this Data Propagation Manager will make sure that the data mining application that you are running or the data mining tool that you are using gets all the data that you require. So this Data Propagation Manager is responsible for this kind of requirement, that is taking data out of the data warehouse for some special purposes, right? And so now we come to the last broad category of subsystems of an ETL system. So managing the ETL environment, and subsystems 22 to 34 are for this purpose. So a data warehouse can have a great dimensional model. That means you have designed the data warehouse well and well deployed applications on top of it. But it will not be successful until it is relied upon as a dependable source of data for data mining. So data warehouse must build a reputation for providing timely, consistent and reliable data to empower the business. And to achieve this goal, ETL system must fulfill 3 criteria. That is of reliability, that is the information that is given is reliable, availability, and this availability should be according to the service level agreements that are signed, and manageability, because if you are not able, so data warehousing is not a one-off thing, so it requires constant maintenance, right? So how do you manage a data warehouse? So it comes under this aspect. So what I've done is I felt that it would be like too much for a first course in data warehousing to talk about managing the ETL environment, and we will discuss these subsystems as and when need arises as we move forward in this course. And subsystems, what I've done is, just for the sake of completeness, I have enumerated the subsystems from 22 to 34 just for the sake of completeness. I'm not going to discuss them at this point, and probably I'll do that if there is a very specific need during the course. So these are the subsystems from 22 to 34. And some of them we may be discussing, like I'll tell you a few ones. I'll mark them on the screen. So backup systems, recovery, and and metadata, because metadata is again a very important aspect, and we have a module on metadata. So how do you manage the metadata repository? So those things will come, and other things are mainly like not suitable for a first course, because there are so many other basic things that we first need to discuss, and then only we can talk about these advanced, I would call them advanced topics related to ETL, of course. So the conclusion as far as ETL is concerned, so key building blocks of ETL system were introduced during these lectures on ETL. And next is to use these building blocks to assemble the ETL system. So building an ETL system is unusually challenging, and 34 subsystems have to work in tandem to do that. So, so what's left in ETL? So designing and developing the ETL systems, the key steps involved in this. So that is the only topic left, and I feel it will be appropriate to cover this after we have discussed fifth module, which is on advanced dimensional modeling. As we saw that there is so much reference to this particular module in the ETL module. Then sixth is on OLAP and multidimensional databases. So again, there were a lot of references for this. Then seventh is about query performance enhancing techniques. So again, like aggregates and some other concepts, indexing, these were kind of covered. These were there in the ETL, some of the subsystems. So they also need some more inputs from module 7. And then finally module 8, that is on metadata. So once we have discussed this 5, 6, 7 and 8, we'll come back to the design and developing the ETL system. So I have given you some idea about the ETL requirements in this module, and what is expected of an ETL system, and what are the subsystems, and what kind of what are their responsibilities, right? So that part I have covered in the three lectures that I have had on ETL, and probably I'll have one more after I have covered modules 5 to 8. So with this, I conclude this module on ETL. As I said, I'll come back to it later, but for the time being, I'm winding up ETL. So the next module that we are going to discuss will be on advanced dimensional modeling. So the basic dimensional modeling features I've already introduced while discussing the grocery store case study. In this module, we'll be taking up some more case studies like the healthcare or the academic data warehouse, the banking, banking sector. So we'll be taking up lots of case studies and talk about the advanced dimensional modeling features. Thank you.